Good evening, beautiful people. Another great way to learn programming and test your game designing skills is to take a very old game, reproduce it, and add a twist or two to it to enhance the gameplay or get it to modern standards. So today's target, as you can see behind me, is Missile Command, a game that appeared on Atari 2600 in 1980s or something. And you're defending various cities from incoming missiles, throwing your own missiles at them, and try to destroy them before they reach the city. Continuing after a t-shirt change and a few days later, never mind, we were supposed to do something, missile command, which will be Earth defense and will be against asteroids, not against missiles. So first things first, we're gonna set up the scene. We are going to create an environment, and start building some shit. I'm gonna set the game to 16:9. I'm gonna set the camera to orthographic, and I'm going to add in here some empty objects I set in here. Okay, so this will be like a house, and I'm gonna build inside the house another object and call it visual. I think this project has the potential of going somewhere, so we're gonna start building stuff properly. I'm not gonna put the graphics directly on the parent object. We're gonna put the scripts on the parent object. I'm gonna keep the visuals separated. That way later, if this project is actually worth anything, we can replace the graphics, the visuals, with something nicer without messing up everything. So I said we're gonna build a small house. Okay, we're gonna use a cube for the body of the house, and we're gonna use another cube, which will be the roof. And this one I said body. This will be rotated 45 degrees like this, and we're going to drag it upwards, like, isn't this an isometric? Yeah, no, it is. Somewhere like this. And let's go and go to 0.7, I think, scale for this one. So this looks a bit like a house. Let's unlink and keep the Z scale at 1. So this will be the house. Let's add a little color. Okay, I'm gonna make a folder called materials. I guess the body of the house will have color yellow. Where is the material here? So yellow. Let's find yellow somewhere around here, 255. And just drag it over it. The roof will be black. Let's just duplicate this, black. Go here, drop it on the roof. This will be the house. So we're gonna defend the city that's about to become a target for a bunch of asteroids, right? So we're gonna have like cannons on the sides, one cannon in the middle, and 3 houses on the left, 3 houses on the right. So let's move this house, right? This house. First of all, let's make a prefab out of it. Let's make a folder called prefabs. Okay, let's take the house and drag it here. Okay, now let's move this. What is this? 3 point minus 3.5, and what is this? Is the middle. This will be where the cannon will be. Let's drag it -3 to be here. Let's duplicate it 2 times. This will be -5, and -7. But we don't have room for a cannon on the left side, so let's bring them towards the center a bit. -4 and -7, -6. I think this will do. And let's duplicate them again. Let's rename them to not have any numbers. Duplicate them, and this will be on the other side, 4, 2, and 6. Okay, so we have this environment right now. I'm gonna build a few. Let's rename these too. Let's add the cannons. What should the cannons look like? I think a sphere. Let's create another empty, call it cannon. Drag it inside the environment. Add another object here called visual, and as children of this, we're gonna use a sphere. For now, a sphere will do. This will be the body of the cannon, and we're gonna add the barrel or something, which will be a cube. A cube that will be 0.1, 0.1, no, 5. Yeah, let's see how it looks. Okay. So let's look from the front again and drag it up like this. But let's also make it 0.1 on the Z-axis. So how does this look? It looks like a ball with a pin in it. Let's choose some colors. Okay. So the barrel should be black, I think, for now, and the body of it should be something like, I don't know, blue. Let's try with blue and see how it looks. Let's remove this and put a blue on it. Come on. I think it's distinct enough from the houses. So this will be the cannon. Let's see where the houses are and drag the cannon here. Okay. Oh, one key came off. Okay. What did I do? It was the scene. I'm gonna save it. Environment cannon. Let's grab the cannon. I think it was 3.5. It's -3.5. It's here. So we're gonna add another one, which will be at what is this house? It's at 6. Let's try -7. Can I say it? -7.5. It's 0.5. Maybe 0.6. Yeah. And duplicate it and remove the minus, and we have 3 cannons. Okay. I don't think I set up the canvas here. But we don't forgive me anymore. So this will be like full HD. This will be on different aspects of resolutions to look the same. Right. Now that we made these, should we make them a bit smaller? Because to keep the scale reference proper, I think for these sizes, the speed of asteroids and missiles will have to be pretty high. So What if we go with a 0.7? Will this look better? 0.6, and we drag everything to minus 1.5, 0.5, in 5, 0.6. So I think this looks like it has the potential of, or even like this, I think it's too small, 0.5, minus 3, minus 2. Does this look a bit better? We have a bunch of area here where things can, so maybe instead of making spaces larger, we add even more houses. Nobody said we have to be exactly like the original. So let's do that. So this was minus 2, minus 9. But now this cannon looks a bit too close to the house. No, this one. I'm looking the other way around. Okay, so this is in the middle. 7.5. Yeah, and this one as well, 7.5. So I have this house, this one, minus 10, 11, and minus 13. Let's duplicate these. What is this? 11, 9, 13. So this is the city you have to protect. When all the houses are destroyed, you lose the city. You lose the game. You have only 3 cannons. They will be shooting where you click on the screen. And the way the cannons are picked is you'll get the closest cannon to the point where you want to shoot that is also able to fire. Because they cannot fire continuously, they have a bit of a cooldown. So if I double click here, first shot will come from this. And if the cooldown is greater than my double click, then it will choose the next available cannon, which will be this one. If you click 3 times, all the cannons will fire. And if you click a 4th time, and none of the cannons can shoot because they're all on cooldown, nothing will happen. Easy. Right, let's make some asteroids, which will be, again, asteroid, another empty object inside, visuals, and let's make a sphere. What else? Asteroid body. The body is a bit big. Should be smaller, 0.3. 0.3. No? I should have clicked this before, so 0.3. I think this is enough. As for the color, I think this gray is a perfect representation. Let's drop it in here. Remove it from the scene yet? No. Let's make also the missile that you're firing. And to hold the data for this asteroid spawner, like how often should it spawn, where should it spawn from the prefab of the asteroid. Let's make another script called asteroid spawner data. And let's open it in Rider, which obviously didn't have anything better to do but to open on the other screen. Here we go. So this is the data. We're gonna rename it because I put an capital S here. Right, and did it rename it in Unity as well? Yes. Be very careful on Mac. The file system is not case sensitive, and changes in cases for file names are not getting picked up by Git clients. Ooh. And then you'll get some extremely stupid errors. And I also misspelled the name. It's asteroid spawner. Right, so now serialized field private game object asteroid prefab. We're gonna make another spawn interval. Now it's minimum spawn interval and max spawn interval. Do we need anything else? So far I think we have everything that we need. I'm gonna expose these variables through getters. Oh, and I need to create a file name asteroid spawner data, and the name of in the menu will be data asteroid spawner data. Great. Now we're going to make a folder called globals where we'll keep these scriptable objects and call one data. This is where we'll store immutable data, and I'll show you later what other type of data we can hold. So we get asteroid. This is the prefab, and right now, because we want to test things fast, we're gonna spawn them really fast, between 0.25 seconds and 0.5. This is how fast they get spawned. In the environment, we're going to add this script, asteroid spawner. Open it up. Let's get a reference to the scriptable object, asteroid spawner data. Asteroid spawner data. Okay, and to launch these asteroids, we are going to use some markers. We're gonna put two objects. Let me show you like this better. Where is the camera? Right? This is the camera. Let's look from the front. Like this. I'm gonna put two objects in the corners, and we're gonna choose randomly a position between these points. This is where the asteroid will spawn, and we're gonna use two more markers at the bottom corners. We are going to choose another random point between them, and that will give us the direction the asteroid will go to. So it will spawn like here and go to this point here. Keep it simple for now. So should I make another object here and call it spawner markers? Okay, and just add some cubes for now, although we will remove the visuals from it. We're gonna keep now let's call them top left, top right, bottom left, and bottom right. So we're gonna use the cubes on them just so we minus 18, 19. Let's keep it at minus 18 so I can see them. I'm gonna drag it up, minus 15 point, minus 16, 17, 16.5, and minus 19. Right. So this will be our top left. I'm looking from the front. And top right will have the same, but with the X positive. What did I do? Did I paste or did I copy again like a moron? Copy position, go to this one, paste position. Okay, so I said 19, it goes here. This one will also have a minus 19, but we'll keep it here, minus 4.5, 4.5. And the bottom right is the same, only with the X positive. What did I copy? Position, paste position, and 19. Now, great. So I said, oh, let's get the asteroid spawner data and also make a list of these mark as game object, top left marker, top right, you're right, I don't know what I did, right, bottom left marker, bottom right marker. Let's assign them while we're here, because I always forget. Top right, bottom left, bottom right. Okay, so this will be on the start method. It will start a coroutine, spawn asteroids. Yeah. And let's create this. It's an enumerator. And yes, import everything you need about it. Right, so we're gonna do this forever. While true, yield return new wait 4 seconds, asteroid spawner data, min spawn interval. I forgot something. Random range and asteroid max spawn interval. Okay, we have waited, and now we're going to instantiate asteroid spawner, asteroid prefab, where where let's use a var called x spawn. It will be random range between top left marker x, what the hell, transform position x. Let's use transform directly instead of game object, because we don't need these game objects, we need their position. So we get their position from the transform. So let's not double call this top left marker and top right marker, right? So the asteroid will spawn at new vector 3 x spawn and top left marker position y and top left marker position z, quaternion identity, and it will spawn with a parent null. That means it will spawn in the root of the scene. I don't want it anywhere. Let's get this asteroid, right? Because we want to do something with it. We need to tell it the direction where it will be going to. And let's compute the direction. X spawn x destination equals to random range bottom. Okay, I wrote some stupid shit here. Destination. Could be a nation. Right. Now we have the point at the bottom of the screen. And we need to tell it. So asteroid get component I direction. Okay. Value equals new vector 3 x destination top left, no, it's bottom left marker position y, because it wanna be at the bottom, and position z. Now we don't have this I direction, right? So we're gonna make this interface, create a script, call it I direction interface, clean up all the shit, and make a property called value. It's a vector 3 value. We'll have a get and a set. Right. Now we need somebody to move this asteroid, and it will be a component that will be sitting on the asteroid. We'll take this direction and move the asteroid in that direction from its starting position using a specified speed. But both the asteroids and the missiles will kind of have the same component needed. So I'm not gonna call it asteroid translator or whatever. I'm gonna make it a bit more generic and call it translator. But it doesn't translate anything, it just moves. So, but yeah, let's call it translator. Let's not debate this too much. This will be a component. It will be a mono behavior, but it will also be an I direction, and it will implement this vector 3, which can be set by somebody. It will also require some data, private translator translator data. Right, we do not have the translator data, so we need to make it. Translator data. It will also be a, I'm too eager, scriptable object. Let's delete the crap. Okay, let's put this up top from now because we'll forget translator data. Put an underscore in front. So it will be still data, translator data. This will be the menu. Okay. What does it have? Private. Speed. Right? Mean speed will be a random between some values. Float. Max speed. Come on. Don't be shy. And we'll have a property public float speed, which will be a random range between these. Okay. Because the rockets will have the same speed, only the asteroid will have varying speeds, just to mix it up a bit. Now we have to go to data, create this translator data will be asteroid translator data. That's why I added the underscore there. 0.2, 0.5. Okay, let's go back to translator. Okay, so this value is a bit obscure, so we're gonna change it to direction because we get confused what that value is. So on update, transform position plus direction multiplied by time delta time, but you also need the speed, and we're gonna organize the operations so we don't multiply a vector with a scalar and then the result will be a vector and multiply it with a scalar again. So we're gonna multiply the scalars first and then multiply with a vector. Big performance gains. Anyway. So at this point we have what we need. So let's go to the spawner. It did set its direction. The asteroid will be spawned where we want. It has its direction and it should be on its merry way. Right? It should work. What we've written so far, it should just work. So this was the script. The asteroid spawner data has the asteroid, which doesn't have the translator on it, and this one doesn't have data, and this is the asteroid data with these speeds. We have set up everything, and now when I press play, asteroids will start coming down towards the Earth. They are not coming towards the Earth, they are coming towards... Some of them are going outside. Mistakes were made. Why are they going outside? So some of them this is very wrong and we have to debug it. Let's go to the spawner script. This one is the at fault. X destination, random range, bottom left marker, position X, bottom right marker, position X. So it's somewhere between these two, or should be. And the direction is wrong. Let's make another variable here. Spawn position is this vector. And spawn position. So it is wrong because we didn't give it a direction, we just gave it the position of the point on the ground. And we need to subtract from the X position the destination one. Let's just destination position equals this. Now it's I just misspelled this shit again. Come on. What the fuck am I typing here? Destination. Ciao. And now nothing works because they're going up. I'm a moron. It's the other way around. Destination minus spawn. That's how the vectors work. You want to subtract from the target the start to go to the target. Great. And now they're coming down over the houses. Let's look from here. For some reason, no. So they come from between these 2 points and always go towards these points, towards somewhere in between these points. And I think we have a very rainy day.